Assalamu alaikum guys, I hope you're all doing well. We looked at functions in the previous video, and we'll be looking at functions again, and we'll be discussing new concepts. So we have a function y equals x squared minus 4 right here in front of us, and let's see what's special about this function. Well, now by looking at this function, you see there are some functions. For instance, this one, no matter what inputs you put into this, okay, you can try any input you want, and there are going to be some outputs that are impossible to get. No matter what values of x, there are some values of y, some outputs that you will never ever get. Okay, for instance, I happen to know that the number, let's say y equals -5, right? You'll never get that, right? You can try every single value of x that you want, and you'll never get to -5, -6, or -8, and so on. Now, how do I know that? Well, I want you guys to pause the video and think about it for a moment. Okay, well, I assume you have tried. uh, well, you have all the tools you need. It's on the graph itself. This is a quadratic, and I chose that on purpose. Now, where's the vertex? Where's the lowest spot on this graph? It is going to be here when x is 0. Well, what is the value of y when x is 0? Well, let's input it into the function. F of 0 will like this, and it's going to be 0 squared minus 4. So we get -4, and that is going to be our y value of y, and so that is our vertex. Now, as you guys can see, that since it's the vertex, the graph is going up in this direction and up in this direction. Okay, it's going up in this direction, and it's going up in that direction. Now, what you notice here is that it is never going to go below -4, right? Another way I would say this is there are some restrictions on the outputs. You can put in a whole bunch of different inputs, but you'll only get certain outputs. Now, you can think of it as a juice maker machine. If you've got fruits and you've got milk and sugar, you're only going to get milkshake out of it, right? You can't get a chocolate sundae. uh, and now let's take a look at another example. Now, I know it's not a function, but I'm still going to illustrate this concept from it. Now, there are certain inputs in this in equation and graph that don't work. You put them in, you try and evaluate them, and the machine breaks down, right? Now, if you go back to my juice maker machine, if you put in a rock in it, it's actually going to break down. So as we saw in the previous example, well, there were some outputs that were restricted. There were some outputs that you couldn't get that you couldn't possibly get, right? For example, -5, right? And now in this one, there are some inputs that you cannot put into the function. Well, let's try putting them in and see for ourselves what happens. Well, as you guys can see the equation here, x squared plus y squared equals 1. We know that this is going to be 1, and this is going to be -1. This is going to be 1 as well, and this is going to be -1 right here. Now, a value like x equals 2, it's going to break my circle. Can you guys see why? Well, nowhere on the circle can x equal 2. Now, if I want to think about it in terms of like trying to put in, it'll become, let's input the value 2 in it. So 2 squared plus y squared equals 1. 2 squared is 4, plus y squared equals 1. Well, if you subtract 4 from both sides, what you'll get is y squared equals -3. And there are no numbers that we know about yet that you can square and get a negative. So therefore, out of this new way of notation, we get this new idea called domain and range. Let me give you a definition for this now. So, domain and range, it's all about, well, if some inputs break our function, right, and if some inputs are impossible to get out of my function, then I want to know what works, what is possible. Okay, so domain simply means what x values I can put in, or what inputs I can put into the function, and also means range means what y values or what outputs I can get. Now let's do a few examples to see what's going on. Well, we have this function y equals 1 over x. Now you can quickly see right here there are some values of x I can put in that are great. I can put in 1, 2, 3, 4, 5, or negative numbers, any numbers, and they are going to be great. Now but there is a value that breaks the rules of the universe. Now before we say what that value is, let's take a look at the graph. Now as you guys can see, the graph is moving upwards in this direction, okay, in this direction, and it's going forward in it's going downwards in this direction as well, okay, in this direction. And what you see here is that it's called an asymptote. You can google what an asymptote is, because this word is, I don't think it's in your syllabus, but I'll just tell you. An asymptote is a curve that basically, it's going towards the y-axis, and it's never gonna reach that. Okay, it's getting closer and closer to the y-axis, but it's never going to actually touch that. And why can't it touch the y-axis? Because if it touches the y-axis, x is going to be equal to 0, and let's see what happens when x is going to be equal to 0. Y equals 1 over 0. Oops, what is this? This is undefined, or undefinable as I like to call it. And if you like, I can give you a long argument for why it's undefined or why it cannot be defined. But suffice to say, for now, x equals 0 is not going to work. In another video, I'll tell you why 1 over 0 is undefined and why 0 over 1 is equal to 0. But for now, what we saw was that it is 0 is not an x value I can put in, right? Now, if you're less than 0, okay, if you input a number that's less than 0, you're okay. If you input a number that's greater than 0, you're also okay. But if you're at 0, you're in trouble. Okay, so I would say for this graph, the domain is going to be the domain. You guys might have guessed it by now. The domain is going to be x can be either greater than 0 or x can be less than 0. It just cannot be 0, right? Now, this is how you write domains. There's other ways to write it, but it's sufficient for your syllabus. Okay, now this is what the domain is. These are the values that I can input into the function. Now let me tell you a way not to write it, and many people make this mistake, but after I tell you this, you're never going to make it. Now some people write this as the domain as x can't be equal to 0. Now this, although this is a true statement, but it doesn't answer the question. Like I'll give an example. Well, if you ask me what my favorite movie is, and I say that I just completely hate Avengers Infinity War, and so that doesn't answer your question. And what is domain saying? What is domain saying? Domain says what values can I put in, what is going to work. Okay, and if you say x is not equal to 0, you're telling me the opposite thing. You're telling me what doesn't work, and it is not the answer. Does that make sense? So for that reason, this is not going to be the domain. This is not going to be the domain, and this is what's actually the domain. Okay, now let's take a look at another some other examples. We'll discuss domain first, and then we'll discuss range after that. Now we've got an equation y equals let's say x plus 1 over x minus 1. Now, well, as you can see in this equation, you can see it that there can be a trouble value. Now if I input values like 3, 4, 5, 6, 7, 8, 9, 10, it is going to work absolutely perfectly, but there is going to be a trouble value. And when is that going to happen? It is going to happen when the denominator is 0. Okay, we don't want that to happen. When the denominator is 0, it gets undefined, right? And so when is the denominator going to be 0? The easiest way to find what the domain is to basically find the trouble value. Okay, and what is going to be the trouble value? It's going to be when the denominator is 0. So when is the denominator going to be equal to 0? It's going to be equal to 0 when this x is going to be 1. So 1 minus 1 is 0. And another way to write is you can basically put this denominator equal to 0. right? That's what you're doing. You're putting the denominator equal to 0 to check which value of x makes this happen, which makes this possible. Okay, what value of x causes the denominator to be 0? Well, now if you add 1 to both sides, you'll basically get x equals 1. Now 1 is our trouble value here. We don't want to input the number 1, because what's it going to result in? It's going to result in something like this. It's going to be 1 plus 1 over 1 minus 1, which is 2 over 0, which is undefined. Now we don't want x to be 1. So the possible values that we can put in the domain, as mathematicians call it, the domain is going to be x can either be greater than 1 or it can be less than 1. It's that simple. It's literally the easiest thing on this planet. Now let's take another example. We have y equals 1 over 2x minus 3. Now again, we see that the denominator can be equal to 0 if we input a certain number into it, and now we want to know what that number is. So let's just put the denominator equal to 0 to find out what value of x causes this equality to be possible. That is why we're doing it. Let's add 3 to both sides. We'll get 2x equals 3. Now we're going to divide both sides by 2. We're going step by step, and we get 3 over 2, which is 1.5. Now we don't want 1.5, and so what is our domain going to be? You guys must have guessed it. The domain, we can put values of x that are either greater than 1.5 or that are less than 1.5. That's literally it. Let's take another example. We've got y equals x squared minus 5. Now in this example, you guys can see that there's literally no trouble value here. You can put in any value you want, okay, and there's going to be no problem in it. You're not going to have a trouble value. So literally the domain is going to be all values of x. We call that all real values of x, and real values means real numbers. What are real numbers? I'll post a video on that, but real numbers are basically it is the set of rational numbers and irrational numbers. Now you must know what those are, guys. You're in AS level, come on. um, or O level, you guys should also know what that is. All real values of x, or the way I like to write it and other mathematicians like to write it, is x belongs to R. That's basically, this is prettier way to write it. You want to impress your examiner, write this: x belongs to R. R is basically the set of real numbers. Well, this isn't necessary, this isn't in your syllabus to learn this notation, but you're my students, guys, come on, you're the best. Okay, so we looked at what domain was. Now we're going to look at what range is. You guys must have guessed it. Range is literally what it is the possible outputs I can get, the possible outputs I can get, the range of possible outputs, or the set of possible outputs I can get from a function. Okay, and let's take an example. Well, we took an example in the start. Let's just take another example. We got x squared minus 6. Now as you guys can see here, that, well, there are two ways to look at this graph. We look at this equation. We can look at it in terms of this equation only, and we can look at the graph as well to visualize stuff. We'll do that later, but for now we're going to look at this equation. Now as you guys can see, the input is going to be squared over here. Okay, so any number, when you square it, it is going to be a positive number, right? So x squared, this number cannot result in a negative number. Now this is the thought process behind solving these questions, and if you guys don't think this way, you're gonna get in trouble. Now x squared minus 6. Now x squared is always going to be positive, right? There's nothing new about that. And then you've got negative 6 in front of it. So let's say your positive number was 3, and 3 got 3, we did 3 minus 6, we got negative 3. Now the number has been reduced to negative 3. Now what I mean here is, if this x squared was, let's say, equal to 0, right? So we could get 0 minus 6, and we could get negative 6, right? If we inputted 0 in the function, we could have gotten 0 minus 6, which equals negative 6. Now if you guys, I want you guys to realize here that you cannot get a number that's smaller than negative 6 here. And why is that? Because if you put in any value of x, it is going to be, if you put any value as x, it's going to be larger than 1 unless it's 0, right? If you put in, let's say, f of 2, you inputted 2, you'll get 2 squared, which is 4, minus 6 is negative 2, and negative 2 is greater than negative 6, right? But the smallest possible value that we can get is this negative 6. And when is that going to happen? When x equals 0. Okay, so the range, what is the range going to be? Well, if we say that the range is going, the y cannot be less than negative 6. If I say that range is basically f of x, which is y, can't be less than negative 6. Would that be correct? No, it won't be correct. Why? Because that doesn't answer our question. We want to know what it will be. So the correct domain, the correct range for this is going to be, the range is going to be y is going to be greater or equal to negative 6. We can get negative 6 if we input, if we input 0, we'll get negative 6. If we input numbers that are greater than 0, we'll get values that are greater than negative 6. So the smallest possible value that we can get is negative 6. Now the graph for this would look something like this. Let me draw it for you guys. Okay, it's gonna look something like this, and this is going to be a, let me use a different color for this. This is going to be negative 6. And now, as you guys can already see, that this graph is going up in this direction, and it's going up in this direction, and so it is never ever ever going to be going to go below negative 6. And for that reason, negative 6 is the smallest possible value that you can get. And so the range is going to be that y is always going to be either negative 6 or greater than that. And for that reason, we say that the range is y is greater than or equal to negative 6. This is our range. Let's take a look at another example. We've got y equals x minus 3 squared plus 7. Okay, well, now again, as you guys can see, that this is a square again, and this is going to be a positive value. So let's it's going to be either 0 or greater than 0, right? So if we take it to be 0, the smallest possible value of y that we can get is going to be 7. And so the range is going to be y is greater than or equal to 7. It's as simple as that. Now, to spice things a little bit, let's take another example. We'll take the same example, but I'm gonna change a small thing. Let's put a negative sign here. Now it's becoming interesting. Now whatever you get out of now whatever you're getting out of this is going to be positive, and when you multiply it with this negative, when this negative sign x upon that, it's going to make it negative. So what you're gonna get is negative values. You're gonna get negative values from this part of the equation. And when you add a negative value to a positive value, right? If you, let's say you added negative 3 to 7, you're gonna get something that's less than 7, obviously, right? You're subtracting 3 from 7. And so 7 is the maximum value that you can get. Okay, you cannot get any number that's greater than 0. Okay, and why is that? Let's see. Let's let's say for a moment that you inputted 3 into the function. What did you get? You got y equals negative of 3 minus 3 squared plus 7, which is negative 0. Negative times 0, which is 0, and 0 plus 7 is 7. And if you had inputted any other value, this is our equation, right? And if there was any other value, it would have multiplied with this negative, it would become negative some number, okay? And then when you add it to 7, it's going to get less than 7. So the maximum, so the biggest number that you can get out of this function is going to be positive 7. And so the range is going to be y is greater than y is going to be less than or equal to 7. It's going, the maximum value is 7, and it can be either 7 or it can be lesser than that. And that's pretty much it for today's video. I hope you guys understand what domain and range are. And this was easy, right? We didn't do many questions in this video, but that's what we're gonna do in the next video. So stay tuned, guys, and the next video is going to be posted today as well. And I'll see you all in the next video. Take care, guys. Bye bye.